Okay, so good afternoon, students. So here I am back. Okay, your chemistry master educator at SISYA class, and welcome you all dear class 10 board exam students from various boards to another thrilling session of chemistry. Okay, so in a last class that we have conducted last week of chemistry, I have just given a basic introduction about chemical reactions and equations. So today will be the part 2 of that session. Okay, so that day we have discussed a little bit about chemical reactions and equations, something about physical and chemical changes, and also about the types of reactions. Okay, the indicators of a chemical reaction as well as the types of chemical reactions. Now today we'll be carrying it out forward, okay, and we'll be discussing the various types of reactions, and we'll be solving some MCQs and PYQs too. Okay, so you all must have watched that video. If not, then you can go to the description of this video and you can just click onto the link and you can watch that video, and if you like it, then please kindly share it to your friends. It's very useful for all of you to score great in your board exams, okay, especially in your chemistry subject. Okay, now many more videos are also going online, okay, of various subjects. Okay, now for that you can just subscribe us, and so now let's move on. Okay, so before moving on, let me just introduce myself. If some of you might not know me, then this is me. Okay, so I am Akash Sharma. Basically, you can call me Akash sir. I am the chemistry master teacher at SISYA class. I have done my masters from CSVTU. I've been teaching since last 10 to 12 years, working since last 15 years. Now I have taught thousands of students. Many of them have been selected in various IITs. Okay, and many of them are just going through a flaunting career. Okay, now I have some PSU experience also, so this is all about me. Now without me wasting much time, okay, let's move forward. Okay, so now before going on to that topic where we left in our last class, let me just give you a quick introduction. If some of you are, hello. Okay, so now if some of you are joining first time, then let me just give you a quick introduction of this chapter. Okay, so that if you are joining now for details, you can just go to the description and watch that video also. Okay, so this is a mind map I have prepared for you. So whatever we have discussed in the last class, we have discussed that what is a chemical reaction, how a chemical reaction occurs. Okay, now what are the evidences and characteristics of a chemical reaction? Okay, the characteristics what you call. Okay, then I have discussed about combination reaction. Okay, so now today we'll be discussing about this decomposition reaction. Okay, then this in decomposition there is thermal, electrolytic and your photolytic decomposition. Okay, then after that we'll discuss about displacement, double displacement, in that there will precipitation and neutralization. Then we'll be discussing redox reactions. Okay, along with that we'll be also discussing the effects of your oxidation and reduction, the effects of redox reactions in our daily lives. And after that we'll be solving MCQs in between, and we'll be solving most important PYQs. Okay, and the most important probable questions that I think that could come in your upcoming board exams. Okay, so do watch this video. Okay, now stay connected. Okay, so let's start. So let's go to the decomposition part. These all I have explained in our last video. Okay, you can go through that and watch it. Okay, it will be very useful to you. Okay, now we have completed till combination. Okay, now we have just started a little bit of decomposition also, but I'll start again for you. Okay, so now decomposition reaction. Now what is a decomposition reaction? So decomposition word itself means to break down. Okay, to break down something. Okay, so the decomposition reaction, there will be only one reactant. Okay, if you are breaking down something, then there must be a single thing that you have to break down. Okay, so there will be a one reactant. Mostly it's a compound. Okay, and when you break down, in order to break down, there can be two types of reaction. Okay, either you have to give heat to the reaction in order to break it down, or either if the reaction is very reactive, then it will release heat. Okay, so it can be exothermic or endothermic. If it releases heat, it will be exothermic. Now if you have to give heat, if it absorbs heat in order to keep that reaction happen, then it will be endothermic. Okay, we'll see it in the coming slides. Okay, so now if a single compound breaks down into two or more substance. So here, as you all know, the left side we call it reactants. So in the reactant side, you will be only having a single compound. Okay, now it can break down up to two or more simpler substances. They can be two or more. Okay, now there are three different types of decomposition reaction which you are studying in your 10th grade. Okay, now in the presence of heat, it is called thermolytic. In the presence of light, it is called photolytic. In the presence of electricity, it is called electrolytic. Okay, now we'll go through all of them one by one. Okay, so now it is the opposite of combination. You all have understood with this reaction type that it is the opposite of combination. Since in combination, two or more reactants combine to form single product. Now here a single reactant is breaking down into two or more simpler substance. Okay, so now let's discuss the first one. So it's thermolytic decomposition. Now thermal means heat. So as you can identify it with the word itself, that without giving heat to some reactions, that reactions don't happen. And those reactions are known as your thermolytic decomposition reactions. Now the most common reaction that we have discussed in the combination also, it is reversible. So its reverse reaction will be in thermolytic decomposition. That's your reaction of limestone. Okay, now limestone, as you all know, when you give heat to it, okay, it absorbs heat and it breaks down into your calcium oxide, that is your quicklime. It is your quicklime and your carbon dioxide. Okay, carbon dioxide gas is released. As I have already told you in the last class, that you can identify the evolution of the carbon dioxide gas through your limestone as it turns it milky. Okay, so now carbon dioxide gas is released. Okay, now this is your thermolytic decomposition that is occurring in the presence of heat. So this is more important here in this reaction. Without giving heat to this reaction, you can't break the limestone into calcium oxide and carbon dioxide. Okay, now there's another reaction. As I have said you, there can be an exothermic reaction, there can be an endothermic reaction. Okay, so now there's one more reaction, that is your exothermic. That means heat will be released here. Okay, so now as you can see this, what is this compound? This is your ammonium dichromate. Ammonium dichromate. Okay, now I have also told you in the last video that how these chemical formulas are formed. Okay, if you know the valencies of ammonium and dichromate, then you can form this formula. Okay, that's very important for balancing chemical equations. Now when it decomposes, it is very reactive, so it decomposes into chromium oxide and nitrogen gas is released along with some moisture. Okay, so nitrogen gas is released along with some moisture. So these are two examples of endothermic and exothermic, both in the decomposition part. Okay, now hello all of you, just concentrate here. Okay, now there's another decomposition, that is a electrolytic decomposition, that is your electrolysis. You all have already learned and known about electrolysis. Electrolysis means whenever electric current is passed in order to carry out any reaction, that is your electrolytic decomposition reaction. Okay, so now here water decomposes water. Okay, if you pass electric current into water, it decomposes into hydrogen gas and oxygen gas. And this reaction is carried out in the presence of electricity. Okay, so now this is your electrolytic decomposition reaction. You can't break down water without passing electricity into it. Okay, now there is another decomposition, that is your photolytic decomposition. This is a very important question in the last 4 to 5 years. Most of the papers carry this question. Okay, that explain the decomposition reaction in the presence of light, heat or electricity. Okay, so you must know its explanation and you must know at least one reaction from each of them. Okay, so concentrate here. Now there is an example of silver chloride. Okay, if you take silver chloride, okay, now it is in the presence of sunlight. If you put it out in the presence of sunlight, it decomposes into silver and chlorine gas. Okay, so it produces silver metal whenever sunlight is put into silver chloride. Okay, so now this is an example of photolytic decomposition reaction. It's not necessary that there will be always be sunlight. Okay, you can also do this reaction or any reaction, any photolytic reaction in the presence of artificial light also. But this reaction carries out in the presence of sunlight. Okay, now some questions for you regarding decomposition. Okay, we'll be solving some MCQs also after completing each topic. Okay, in the end we'll have some MCQ, some PYQs. Okay, so now the MCQ for this. So I've already explained these topics before that. Okay, so you all must be comfortable in answering these questions. Okay, now the decomposition of water into hydrogen and oxygen. So how to solve an MCQ? What's the trick? So first just search the important words, okay, the keywords in any MCQ, okay, because you have to solve the MCQ very quickly. You can't put much time into it. So just search the word that is your keyword. Okay, now here the keyword is decomposition. Okay, now we understood that it's a decomposition example. Okay, now in decomposition we have learned three. We have learned thermolytic, we have learned photolytic, and we have learned electrolytic. Now just see what is decomposing. Water is decomposing. Now for that you have to remember few examples. Okay, now if we remember that water, we have learned that water can't break down without the passing of electric current, then it's electrolytic. Then you don't have to read the whole question again and again. If you are able to find out the keywords in any MCQ, you can solve that MCQ within seconds. Okay, so and this you can apply in all the subjects. Okay, so this is your electrolytic decomposition. Okay, if anyone is having any doubt, you can just write it in the chat box. Okay, I'll clear it along with the video. Okay, now the next one is your burning of coal. Okay, now these all of you have learned in your small grades. Okay, burning of coal. Okay, you must all have learned in the 8th grade. Okay, so coal, if I take an example of coal, coal contains carbon. Okay, so if I burn it, now burning means combustion. Burning means combustion. So if I burn it in the presence of oxygen or air, it will form carbon dioxide. Okay, and it will release some heat. Okay, so now it will release some heat. So if any reaction is releasing some heat, then it is an exothermic reaction. The same concept is used in our thermal power plants. Okay, their coal is burned to produce coke, and it also releases heat, which is now then converted into electricity. Okay, now there's one more question. Okay, why is it necessary to balance a chemical reaction? Now this is a very basic question, but you all must know about it. Okay, so why is it necessary? It's necessary, yeah, conservation of energy. Some are saying conservation of motion, but it can't be motion. Okay, good afternoon all of you. Now just remember that there are two laws that we have learned in grade 9, laws of chemical combination. There are two laws. One is your law of conservation of mass, another one is your law of definite proportion. Now where these two laws are used? These two laws are used in balancing a chemical equation. Okay, now where are they used? So now why is it necessary to balance a chemical reaction? Because of law of conservation of mass, which says that the total mass of reactants must be equal to the total mass of products. Okay, so the total mass of reactants must be equal to the total mass of products. So now this balancing follows law of conservation of mass. I have also told you another law, that is your law of definite proportion. Where is that used? That is used to form a chemical formula. Okay, if you want to form a chemical formula, there you will use law of definite proportion. Okay, so the answer is your law of conservation of mass. Okay, now which of the following is not a decomposition reaction? Okay, now I have told you about three types of decomposition: thermolytic, photolytic, and electrolytic. Now just see the options carefully. Okay, now in first I am saying calcium carbonate. Now quickly you must remind it that calcium carbonate is CaCO3. Okay, now we have learned it, some heat is released. Okay, now if you don't give heat to this reaction will not occur. If you are heating this reaction, that means it will be thermolytic. So it is a decomposition. Now the second one is electrolysis. It is, the name already suggests that it's a electrolytic decomposition. Now the third one is burning of magnesium ribbon. Okay, now if you are burning something, now if you are burning an element, now burning can't take place without the presence of oxygen. Okay, now if there are two elements, then it can't be a decomposition. So you can stop here only and you can just see that this is the answer. Okay, now just let's see the last option, boiling water. Now when we boil water, the liquid state of water gets converted into steam. So here the change of state is taking place. No new substances formed. So both of them are not decomposition reactions. So search for keywords while solving MCQ. Okay, then you will not be taking much time to solve that question. Okay, and the answer will be more or less correct. Okay, next. Yeah, now moving on to the another reaction, that is your displacement reaction. Okay, so the next one is your displacement reaction. So what is displacement? What does that displacement word means? Displacement words means replacing something. Replacing something. So what are we replacing here? Okay. Yeah. So in the last question, the answer is C and D both. Okay. Neither boiling, okay, nor your magnesium ribbon. Both are not decomposition reactions. Yeah. So now in displacement reaction, you are replacing something. Now what will you replace? So in your third chapter, metals and non-metals, you have learned about reactivity series. Okay. Now what's the reactivity series? So it's something like this: potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, then silver, then gold, then platinum. So this is somewhat your reactivity series. What does this show? This show the order of the reactivity of the elements. How these metals react in the order. Okay, the metals that are kept in the top are most reactive metals. These are most reactive because of their valencies. Okay, now the middle ones are the medium reactive metals. And the last ones are the least. Silver, gold and platinum. Okay, so now these you all must remember. It will help you in each and every chapter. Okay, of your 10th grade. Okay, so now what's displacement? Those reactions in which a more reactive element will displace a less reactive element. If a more reactive element displaces a less reactive element, that is your displacement reaction. Okay, now just see an example. Okay, so you can see that if we react zinc with, or if we put zinc in copper sulfate solution. Now here are two metals. You just have to concentrate on the metals, zinc and copper. Now which comes above? Zinc comes above than copper. So zinc is more reactive. So if zinc is more reactive, it will displace copper from its solution and it will form zinc sulfate. And copper will be deposited on the zinc. We'll solving MCQ also on it. Okay, there is one short question that comes from this topic, displacement reaction. Either it will be a MCQ or a short answer question. Okay, or a case based. In case based questions also questions comes from displacement. So remember this example I will be asking you in the MCQ. Okay, so here copper is getting deposited on the zinc. Okay, and the color of the solution is changing from blue to green. It is changing from blue to green. Remember these points. Okay, and copper is getting deposited on the zinc. Next, displacement reaction. So now this what I have given you an example. You can also understand it through this, that if a metal that is more reactive, that is reacting in a compound or that is dissolved in a compound, then if it is a more reactive element, it will displace the least reactive element from here. Okay, and it will form a compound. The least reactive element will be deposited on the other electrode. But if a least reactive element reacts or dissolved in a compound of more reactive element, then there will be no change and no reaction will occur. Okay, no reaction will occur. Okay. Okay, fine. Now, this is another example of zinc and hydrochloric acid. Okay, so if you dip a zinc rod in hydrochloric acid, as I have already shown you, that zinc lies above hydrogen. So it will displace hydrogen from here and it will form zinc chloride, and hydrogen gas will be released that you can observe in the form of bubbles. Okay. Now, moving forward, now comes your double displacement reaction. Okay, the last of 4 of them. Okay, so the double displacement. So as in the single displacement reaction, a single element was getting displaced because of the reactivity series. Okay, so now in double displacement reaction, there will be two compounds. As you can see here, A, B and C, D. These are two compounds. Okay, now both are ionic compounds. Okay, that is a necessary. Both are ionic compounds. Then only they can break down into their respective ions. Okay, and both will displace each other. Okay, so if the ions are exchanged between two reactants and two new compounds will form, then it will be a double displacement one. Okay, now let me explain you with an example. Okay, so concentrate here. There are two types of double displacement. One is precipitation. This is also a very important topic for your board exams. And another one is your neutralization. Okay, now precipitation and neutralization. Now what is precipitation? So precipitate means anything that is insoluble. Okay, if you dissolve a solute in a solution and that's instead of dissolving, that solute lays down in the bottom. Okay, that means that is an insoluble solute. So that insoluble solute is your precipitate. So it is nothing but a insoluble solute. Okay, and how it is formed? It is formed by mixing of aqueous solution of two salts. Okay, that means the aqueous solution that means solution in water. So if you mix the aqueous solution of two salts, here we are taking silver nitrate and we are taking sodium chloride. Okay, now if you mix these two compounds, the aqueous solution of these two compounds, you will form that silver is containing a valency of +1. Okay, chlorine is having the valency of -1. Okay, so it will displace and it will form AgCl. Similarly, nitrate is having valency -1 and sodium is having valency +1. So they form a compound sodium nitrate. Sodium nitrate and silver chloride. So this is the reaction, and here what you will observe? You will observe a white precipitate, as I have tried to show you with a diagram. As you can see it in the test tube, that if you mix these two compounds, after some time you will observe that silver chloride, a white precipitate is formed that is insoluble in it, that is visible, and these white precipitate is AgCl. This is also important for your MCQs. Okay, questions comes from these topics. Okay, so I hope this is clear to you. Yes. Now, another example of precipitation. This is also very important from the exam point of view. So I have kept this example also. Now, if you mix lead nitrate, this is your lead nitrate. If you mix lead nitrate with potassium iodide, now potassium is having valency +1, iodine is having -1, lead is +2, okay, nitrate is -1. Now lead will combine with iodine. Since it's +2, that's why it becomes PbI2. Okay, and since these are +1 -1, they cancel each other and they will form KNO3. Okay, so now lead iodide is formed. Now this lead iodide is your bright yellow precipitate, as you can see it in the video itself. Okay, so you can see it here, you can see it. Okay, so as you can see it, the yellow precipitate that you can see in the test tube, this is your lead iodide. Okay, I hope it's clear to you. Okay, so now let's move on to the another reaction of double displacement. So this is another type, that is neutralization. This also you know. Okay, what is neutralization? Whenever we think of neutralization, one thing that comes to our mind, that is salt. Salt is neutral. And how is salt formed? Salt is formed by the reaction of acid and base. Okay, we'll discuss it in detail in our next chapter. Okay, but this is an example of double decomposition. Okay, so whenever there is a reaction between an acid and a base, okay, I'll give you an example also, then always a salt is formed along with water. And how? By the exchange of ions. That is your neutralization. So this is an example of neutralization. This is the most common example. Okay, now the common salt that we all use in our daily lives. Okay, now this is the common salt, that is your sodium chloride. Sodium chloride. This is your common salt. Okay, now how it is formed? It is formed by the reaction of HCl, that is your hydrochloric acid, and your sodium hydroxide. So this is a base. Anything that contains OH is a base. Anything that contains H in abundance is your acid. So whenever it reacts, this H and OH forms water, and your salt is formed from NaCl. This is the sodium chloride. Okay, so this is also a double decomposition reaction. Okay, now another example of double decomposition. Okay, now this is also an important question regarding your case based questions and MCQs. Okay, so now as you know that our body is basic. Okay, because of the HCl that is present, mostly because of the HCl that is present in our stomach. Okay, now this hydrochloric acid, now if it goes on increasing, okay, and it gets excessive, then we get acidity problems. In order to neutralize that, we have to add some base into our body. And what is that base? That base is called your antacid. That neutralizes the effect of that acid. Okay, and which is the base that is used here? It's called milk of magnesia. Remember this, I'll be asking you in the MCQs. Okay, so it is milk of magnesia. Okay, and the formula is your MgOH twice. That is your magnesium hydroxide. Magnesium hydroxide. So whenever you add this magnesium hydroxide, okay, whenever you take this tablet, okay, whenever you're facing acidity problems, okay, now it will neutralize the acid and it will form magnesium chloride, that is your salt, along with water. Okay, so this somehow helps us in solving our acidity problems. Okay, now some questions, okay, regarding displacement and double displacement. Okay, now all of you ready? Yeah, redox reaction will be after that beta. Okay, after these questions we'll be doing redox reactions. Okay, so now, yeah, now this is the first question. Okay, if iron reacts with copper sulfate, then iron sulfate is formed along with copper. Okay, now here iron is displacing copper, as you can see here. Iron is displacing copper. Now how iron displaces copper? Can all of you tell me the answer? How iron displaces copper? Because iron is more reactive than copper. I have already shown you the reactivity series. Okay, zinc, iron, lead, copper. Okay, so since iron is more reactive than copper, that's why iron displaces copper here. Yeah, it's B. Next question. All of you be active. I'm expecting correct answers from all of you. Okay, now the next one is, what will happen if you place a strip of zinc in copper sulfate? Now the keywords here are zinc and copper sulfate. So just circle down the keywords first. Now zinc and copper sulfate. Now just remember the reactivity series. Is zinc lie above copper? Yes, it lies. Then it will form zinc sulfate. Okay, it will form zinc sulfate, and what will happen? Copper will be deposited on it. Okay, so now is any of these two words in the options? Yes, there is an option D where copper is getting deposited. Even if we don't know the color of the solution that is formed, this zinc sulfate is colorless. But even if we don't know that, we know that whenever there is a displacement reaction, the displaced metal is deposited on the other. So if copper is getting deposited, even if you remember that, then also you can solve this MCQ. Understood? So your answer will be option D. Okay, so your answer will be option D. Now, next question, which of the following is a displacement reaction? Okay, now just see the reactions quickly. Okay, I will solve this. So now here Na will react with Cl forming NaCl and H with OH. So double displacement, so this is not the answer. Now here Ag is reacting with Cl forming AgCl, Na with NaNO3. So this is also double displacement. Now here zinc is displacing copper. Okay, and forming zinc sulfate, and copper is displaced. So this is your answer. Okay, this is your answer because this is your combination. So this also can't be displacement. So your answer is C. Okay, now next question. When sodium sulfate reacts with barium chloride, now here barium sulfate is formed. This sign of an arrow downwards denotes that it is a precipitate. It is an insoluble precipitate. If a sign with an arrow upwards, it shows the gas evolved. Always remember these signs, it's very important. And if the arrow is downwards, it shows the precipitate formed. That is an insoluble precipitate. And we know that the precipitation reaction is an example of double displacement. So simply from this arrow, you can answer this question, even if you don't know the reaction. Understood? Okay, let's move forward. Now, which reaction is a double displacement reaction among them? Now, just see the double displacement reaction. We need two compounds. Okay, so now there in option A there is only one compound, in option C there is no compound, in option D there is one compound. So you can quickly select the option B. You don't have to go through the reaction also. Just try to solve the MCQs as quickly as you can. Okay, but you have to solve them correct also. Okay, so for that you have to just see the key points, what I am pointing out here. Okay, that what points you have to remember while solving MCQ. Next, oxidation and reduction. Now let's come to your redox reactions. Okay, so now talking about redox reactions, all of you have seen this nail. Okay, and you know that this nail, if it is kept in exposure to air and moisture, it turns somewhat like this, a brown colored layer. What is this brown colored layer? This brown colored layer is your rust that is putting out in the iron. Okay, now how it got rusted? In the presence of oxygen and moisture. Okay, so now there comes the concept of oxidation and reduction. So in simple words, I'm just trying, because there is one short question from redox reaction. Okay, so now here we'll be dealing with what is oxidation, what is reduction, what is your oxidizing agent, what is reducing agent. Along with that, we'll be solving many MCQs related to it. Okay, so it gets clear. Okay, now if anything that has your extra electrons, it will donate the electrons. Okay, now if anything that is donating electron, that means it is getting loss of electrons. Now loss of electrons means your oxidation. If something is losing an electron, that means it is oxidized. Remember this word. Okay, now this is your oxidized donor because it is losing an electron. That is your oxidation. And if it is oxidized, if it is losing something, okay, that means it is a reducing agent. So wherever there is an oxidation, it is your reducing agent, because it is oxidizing itself and it is reducing something. Okay, now if an electron is lost, then someone has to gain that electron. Okay, so where the electron is accepting, that one is your reduced acceptor. So here reduction is going on wherever the electron is gained. So it is gain of electrons. And if it is gaining an electron, then it is itself getting used as an oxidizing agent. So if it is itself getting reduced, it will oxidize something. Okay, if you are itself getting reduced, then you will oxidize something. So it will be your oxidizing agent. So in simple words, you can define it as, if there is an addition of oxygen, or what does this oxygen denote here? It is denoting a non-metal that is having, or you can say it, anion. Okay, so if any anion is added, okay, or oxygen is added, or if hydrogen or any positive element, any cation is removed from a compound, that is your oxidation, and you call it as oxidized. Okay, and that is your reducing agent. Okay, and it involves loss of electrons. So just remember oxidation, the opposite will be your reduction. So what will be your reduction? Now here the addition of either hydrogen or any electropositive element or cation, okay, or removal of oxygen or any electronegative element or anion will be your reduction. So it will be called reduced, and something that is reduced, it itself works as an oxidizing agent, because if it is getting reduced, it will oxidize something. Okay, But oxidizing agent means if there is a reduction somewhere. Now here there is a reduction due to the add of hydrogen or removal of oxygen. Now if something is getting reduced, now it will oxidize something, the electron will go somewhere. Okay, so if it is oxidizing something, it will be your oxidizing agent. And it is denoted by gain of electrons. Okay, so whenever there is a gain of electrons, it's oxidizing agent. Okay, whenever there is a loss of electrons, it will be reducing agent. Now, redox reaction. So redox reaction is that reaction in which oxidation and reduction takes place together. So if oxidation and reduction takes place together, that is your redox reaction. Okay, I have just tried to explain you an example here. So just concentrate here. Now you can see that this is a copper oxide. This is also a very important example. Okay, it has been coming in exams since many years. Okay, so this is copper oxide, black copper oxide. Now if hydrogen gas is passed through it, what you will observe? You will observe that since hydrogen is more reactive than copper, this is an example of displacement also. Since hydrogen is more reactive than copper, it will displace copper from here and the copper metal will be displaced and hydrogen will react with oxygen to form water. So you will get copper metal here. Now as you can see here there was oxygen, but here there is no oxygen. So loss of oxygen, simple, keep it simple. Here there is loss of oxygen and loss of oxygen means reduction. And if it is reduction, it will be your oxidizing agent. CO. Okay, now here hydrogen is gaining that oxygen. So gain of oxygen. So if gain of oxygen, then it's your oxidation and it is your reducing agent. Simple, keep it simple. Okay. Yeah. But it is called redox reaction because it is a combination of two words. This RADE denotes your reduction and this OX denotes your oxidation. And since both of them is occurring in the same reaction, that's why it is called redox reaction. Next, reducing agent, I have just told you, okay, that reducing agent means oxidation. You have to search for oxidation. So oxidation means loss of electrons, or you can say that gain of oxygen, addition of oxygen. So where oxygen is adding? So oxygen is adding here. So this is your reducing agent. Now exothermic reaction. Okay, now exothermic, endothermic, all of you have been studying since your lower grades. Okay, and we have been discussed in this video also. Still, I'll just give you with an example. I'll explain you that any reaction that produces energy, in which energy is released or evolved, or you can say that highly reactive chemical reactions are exothermic. For example, reactions with sodium, reactions with potassium, these reactions are your exothermic reactions. The best example is your neutralization reaction. It is an exothermic reaction because as soon as you mix both, that means hydrochloric acid and sodium hydroxide, it quickly forms salt and heat is released. That is your exothermic reaction. What is endothermic? Just the opposite of it. Okay, here you have to supply heat in order to carry out that reaction because the elements are not that reactive. Okay, so here you have to give heat, so heat energy will be absorbed. For example, decomposition of calcium carbonate. Mostly decomposition reactions are endothermic because without the presence of heat, light or electricity, these reactions can't be carried out. Okay. Now some more questions related to your redox reactions. Okay, so see here. Now here zinc is present. So how will we solve this quickly? If we have to tell reduce, that means we have to tell where reduction is carried out. So reduction means loss of oxygen or addition of hydrogen. So here can you see loss of oxygen here? So if here there is loss of oxygen, okay, then this is your reduction. Then what is reduced? Sulfuric acid is reduced. Wherever there is a reduction process, that is your reduced. Okay, now next one, if silver nitrate AgNO3 is mixed with sodium chloride NaCl, now you are seeing a white solid appearing, white solid compound. Okay, and whenever an insoluble precipitate occurs, beta, it is an indication of your precipitation reaction. So you don't also have to write the reaction. If you're seeing that anything solid that is appearing in the product side, that means it's an insoluble precipitate, and that will be your precipitation reaction. Okay, example of double displacement. Next, NaOH plus HCl gives NaCl plus H2. As you can see, Na reacts with Cl, H reacts with OH, so double displacement. And in double displacement, there is no option like double displacement. So in double displacement, there are two categories: precipitation and neutralization. Now, for precipitation, you need an insoluble precipitate, but there is no arrow here nor here, so it will be your neutralization reaction. Okay, so if you remember the key points, you will be able to solve these questions very quickly. Okay, but oxidizing agent is something that is getting reduced. Where there is a loss of oxygen, it will be your oxidizing agent. Now, next one is your, when you add dilute sulfuric acid H2SO4 with your sodium hydroxide, that is your NaOH, then heat is released. That means energy is released here. Okay, now in whichever reaction energy is released, that is your exothermic reaction. So your answer is option B. You don't have to write the whole reaction also. Next, yellow precipitate. We have just seen a test tube with a yellow precipitate. Okay, few slides before. Now just remember that question. Okay, that's when a yellow precipitate is formed. So yellow precipitate is formed when lead nitrate. Let's just see the reaction also. PbNO3 twice reacts with potassium iodide, Ki. Okay, now lead will form compound with I, so it will become PbI2. Okay, now it will become KNO3. Now you can balance that. You put 2 here, you put 2 here. Now it's balanced. Okay, so now this is a reaction. And what is the precipitate formed? The precipitate formed is your lead iodide. That is yellow in color. Okay, next, few more questions for you. So which property of metal determines that whether can they displace other metal or not? That is your reactivity series. So the property is called reactivity. Now, in a double displacement reaction, in double displacement, you know that both reactants exchange. What do they exchange? They exchange either ions or radicals. Okay, so your answer is option B. I have already showed you through an example. Okay, the next one, in the reaction, this is the reaction. Now you have to find reducing agent. Now if the reducing agent you have to find, then it is the opposite is oxidation. Then you have to find where oxidation is happening. Oxidation means gain of oxygen. Now as you can see here, zinc is gaining that oxygen. So here the oxidation is happening. So zinc is your reducing agent. Okay, so if you have to find reducing agent, find where the oxidation is happening. Okay, and where the oxidation is happening, to which element, okay, that will be your reducing agent. So zinc is your reducing agent. Hello. Now, in the reaction, now this reaction, now here magnesium ribbon burns with oxygen to form magnesium oxide. This is a common reaction, you all know. Now which element is oxidized? For oxidized, you must search for oxidation. So if I have to search for oxidation, now addition of oxygen, so magnesium here gains oxygen to form magnesium oxide. So magnesium is your oxidized element. Okay, so the answer is your answer is your magnesium. Okay, magnesium is your oxidized. Okay, oxygen is reduced. Okay, next, I have to tell the oxidizing agent here. Now oxidizing agent means I need to find where reduction is happening. Reduction means either addition of hydrogen or reducing oxygen. Okay, now see here, if oxygen is not present, any electronegative element, you can see chlorine also present here. Okay, now how will it work? Now you can see here there is potassium iodide, potassium valency is +1, so iodine will be -1. Write the valencies here first. Now if an individual element or molecule is present, that always has an oxidation state 0. Now remember this point. If an individual element, okay, or a molecule is present in a reaction, its oxidation state will always be 0. So here chlorine molecule, the oxidation state will be 0. For iodine molecule also it will be 0. Now here again, the valency of or the oxidation state of potassium is +1 and for chlorine it's -1. Now see where there is loss of electrons. As I have told you, loss of electrons means oxidation. Okay, and gain of electrons means reduction. Okay, now if I have to find oxidation state, I have to find reduction. So I need to find the gain of electrons. Now if I see here, this I is getting -1, it is changing to 0. Okay, now the Cl is going from 0 to -1. So here there is loss of electrons, and here I, there is your gain of electrons. So if the gain of electrons, then it is your reduction, this Ki. So if it is getting reduction, that means it is oxidizing agent. So your answer is Ki. Okay, likewise you can find the answers of these redox reactions. Now, some reactions has single oxidizing and reducing agent also. Okay, for example, H2 plus O2 gives H2O2. Now here there is only one compound that is formed. Okay, so now if H2O2 is breaking down, it will form H2 plus O2. So now here H2O2 will be both acting as oxidizing agent and reducing agent. So your answer is H2O2. This is also an important question. Okay, H2O2 is a common oxidizing and reducing agent in different reactions. Now another reaction, we have to find the reducing agent. Reducing agent means oxidation. What do you mean by oxidation? Now oxidation, if I have to find oxidation, I have to find addition of oxygen. Okay, so now here oxygen, there is only one oxygen atom present, but here there are two oxygen atoms present. Okay, but now here you can see there is an oxygen, but there is loss of oxygen. So if there is loss of oxygen in iron oxide, then it's reduction, then this will be your oxidation. And if this is your oxidation, this will be your reducing agent. So your answer is CO. Let's quickly move on. So the substance that is getting reduced is your oxidizing agent. Because if the substance is getting reduced, there is a reduction going on. And if the reduction going on, it will be your oxidizing agent. Okay. Now, next, reaction between hydrogen and chlorine. Okay, as we all know, H2 plus Cl2 gives HCl. This is your balanced chemical reaction. Okay, now this is an example of what? So here you can see that no precipitate is formed, so it will not be a precipitation reaction. Okay, neither it can be a double displacement. Okay, now remains 2. Now it can't be a neutralization as this is neither an acid nor a base. Okay, now it will be a redox reaction. But a precipitation reactions are those reactions in which an insoluble precipitate is formed. Okay, and these are double displacement reactions. You can identify it with the arrow downwards. That will be your precipitation reaction. Okay. Now the answer will be your redox reaction. So even without solving, you can just follow the policy of cutting down the negatives, then you will get the positive answer. Okay, so you can just do the elimination process, eliminate the wrong ones, then you will get the correct one. Next. So the last topic of this chapter, that is effect of oxidations, then some PYQs. Okay, so these are some common effects: corrosion, rusting, rancidity, and combustion. These are some common effects of oxidation, that means of addition of oxygen. Due to the presence of oxidation, these reactions occur, okay, in atmosphere. Okay, or you can say these reactions are present around us. So how do these reactions occur and what do they form? What are their effects? What are their applications? We'll discuss this. Okay, now let's start with corrosion. So you all know corrosion. You have been studying it from your lower grades also. So it is a change that is not useful. Okay, it mostly occurs in metals. Okay, and it occurs in the presence of moisture, air, acids, and bases. Okay, it is whenever any metal is attacked by either by moisture, air, acids, and bases. Okay, then there is a change in that metal. Okay, it deteriorates that metal. Okay, and corrosion is carried out. Okay. Now these are some preventives of corrosion. Okay, if you want to prevent that corrosion, or if you want to prevent metal getting corroded out, then you can apply all of them. Okay, any one of them. Okay, so now painting, you all know, we can paint that metal. Okay, it reduces corrosion as it is reducing the attack by moisture or air. Now galvanization is applying zinc layer on oxygen, zinc layer. Okay, if you apply that zinc layer on iron metal, okay, then that is called galvanization. Then a coating is formed which prevents further corrosion. Electroplating using electricity, these all are methods that uses electricity, okay, to prevent a metal from getting corroded out. Okay, so you must know the basic about corrosion. Rusting. So what is rust? So rust is nothing but whenever in iron, this is the formula of rust. The moisture can be of any content, that's why I have written X here. Okay, it can be 1, 2, 3. Okay, now this is the formula of rust. Okay, so whenever iron is attacked by oxygen and moisture that is present in the air, it forms a reddish brown layer above it. Okay, that is slowly deteriorating that metal, and finally the metal erodes. Okay, that is your rust. Next, prevention. How will you prevent rust? Okay, by painting, by greasing, by reducing the friction. In simple words, either by reducing the friction so that it doesn't get corroded out or rusted out, or by putting a layer of something over other. Okay, for example, by putting the layer of zinc over oxygen, it's called galvanization. Rancidity. What is rancidity? Rancidity is your oxidation of that fatty oils present in the food. Okay, if it reacts with oxygen that is present in the air, it changes its taste, it changes its color, it also changes its composition, and then that is not eatable. Okay, so now then we say that the food is rancid. Okay, now we can't eat them. Okay, so it is because of the oils and fats that is present in the food items. Okay, in the presence of oxygen that is present in the air, they get oxidized. Okay, and we can't eat them anymore. Yeah. How can we prevent rancidity? How can we increase the life of the food items? Okay, so for that you all must be using that in your home, these airtight container boxes, okay, that we have. Okay, if we keep our food items, especially the oily food items, in then it just increases the life and decreases the oxidation. It's not that you can just eliminate the oxidation, you can only decrease the oxidation, you can't eliminate it. Okay, you can just decrease the oxidation using this airtight containers. You can delay it. The food will be well for eating for a longer period of time. Okay, now using antioxidants. Okay, some antioxidants are also there that you mix, that decreases its reaction with oxygen. Now storing food in refrigerators, that we all do. Okay, now packing with nitrogen gas. Okay, as you have seen in chips packets, when you open that chips packet, okay, it is good or it is fresh for a longer period of time. How? Before opening, even for packing for a longer period of time, because of the nitrogen gas that is present inside it. Okay, it is put inside it in order to reduce that oxidation process, so that the shelf life of the chips packet can be increased. Okay, and we can use it for a longer period of time. But as you have seen, as soon as we open out the chips packet, okay, and if we keep it out for a few minutes, you can say, then you can see there is a change in the crispiness or the structure of that chips. Okay, because of the reaction of that oxygen. Okay. Next, the last one is your combustion. So combustion, the easiest example is your methane gas. That is also called your biogas. Okay, so that is your CH4. Now, if it is burned in the presence of oxygen, so if any fuel, okay, biogas is also a fuel. If any fuel is burned in the presence of oxygen, it will release carbon dioxide gas. Okay, along with water here, some moisture and some energy. So some heat is released. So this is an example of exothermic reaction. Okay, fine. I hope all these topics are clear to you. Okay, now some MCQs and PYQs. Okay, so now which metals does not get rust easily? So for that you have to again go back to the reactivity series. Those elements or those metals which come in the bottom of the reactivity series, they will not get rusted easily. So in the bottom most out of them, silver is the metal that will not get rust very easily. Aluminium also doesn't get rust easily, but if you have to pick one out of aluminium and silver, it will be silver. That's why gold, silver and platinum are used to produce ornaments, okay, to make ornaments. Now, which is an example of corrosion other than rusting? So, formation of green coating on copper. Copper is also a very reactive metal. Then copper is also a very good conductor of heat and electricity. But in the presence of moisture in air, it gets a green coating on it. Okay. So that is also a form of corrosion. But that is not rusting, but that is corrosion. Now, if silver, I have already told you an example, if silver is put out in the presence of light, then it forms silver chloride, that is black layer, somewhat black layer, okay, that is called your tarnishing of silver, okay. So these two are the examples of corrosion that is not rusting. Now, rancidity occurs due to, I have already told you that it is due to the oxidation of oils and fats. This is your rancidity. Now, which of the following will prevent rancidity? So I have just told you out of these, you can just pick out the option. That is a very easy question for you. It is storing in airtight containers. That is your prevention of rancidity. Now, which of the following statements about corrosion is true? So corrosion basically erodes the metal. It deteriorates the metal. So it damages the metal surface. Now, some more questions. Okay, so now electrolysis of water. So now just do the reaction of water quickly. Break down water into hydrogen and oxygen. Balance it. So if you balance it, it will be looking somewhat like this. Now, if I see here, the mole ratio of hydrogen and oxygen, then you can, these the numeral that is present in front of an element or a molecule, that is your mole. Okay, so 2 moles of hydrogen, and if there is nothing written it, then it is 1. So 1 mole of oxygen. So the ratio will be 2:1. Next question. So which of the following gases is used to store fat and oil containing foods? So nitrogen gas is used to prevent the oxidation or reaction with oxygen. Now some assertion reasons also, because assertion reasons are also coming in exams. Okay, and some students find it difficult to solve those assertion reasons. So I've just tried to put some important assertion reason questions, and I'll just explain you how to solve that assertion reason question. Okay, so now the first one assertion is your decomposition of silver chloride. Now you have seen that reaction, decomposition of silver chloride gives silver metal and chlorine molecule. So now this is the reaction of silver chloride. Okay, now it is used in black and white photography. Okay, we all know that. Okay, since it is present, it is done in the presence of light. Now light provides the energy for this decomposition. So since it's an example of photolytic, so the reason is also correct. Okay, so both A and B are true, and R is the correct explanation of A. Okay, so answer will be your A option. Now, why is respiration considered an exothermic reaction? Now, what is respiration? We have learned this reaction in our lower grades. So respiration is basically the breaking down of food that we eat. Now, basically when we say food, we say glucose. Okay, so if I take glucose here, that is your C6H12O6. And if I break down in the presence of oxygen that is already present in the body, then it gives, then it gives CO2 plus H2O plus high amount of energy is released. So as you can see here, that high amount of energy is released when we eat food. So that food, the chemical reaction that is occurring, that is converting chemical energy, okay, that chemical energy, okay, and that gives our energy to our cells to perform various functions, okay. That's why this is an exothermic reaction. Now this is a PYQ. Now we will be solving some PYQs and some most probable questions that could be asked from this chapter in your upcoming board exams. Okay, so listen it carefully. Hindi, yeah, okay. I'll just try to keep it in mix. Okay, yeah. Now a shiny brown colored element. How to identify the answer? Okay, in any question. Now brown colored element. The first element that comes on mind, हमारे दिमाग में सबसे पहले क्या आता है when we hear brown colored element? Now comes copper. Okay, so remember, if any time you go through a question which says a brown colored element, then just first write copper here. Okay, now on heating in air, whenever we heat something in air, अगर हम उसको air से react आते हैं, now air means oxygen here. Okay, so if I am reacting it with air, now copper reacts with air. I have already told you this reaction, copper oxide is formed. Okay, now balance this reaction. Now put 2 here and 2 here also. So this is a balanced reaction. Now copper oxide is formed. This is your black colored compound. Okay, so now by just identifying the few key points or keywords in the question, you can go through the solution very quickly. Okay, so the element is your X is your copper, and the black color compound that is formed is your copper oxide. Okay, this has also been asked since last few years. Okay, now another one, what is the color change when an iron nail is kept? So quickly write this iron. Now it is kept in copper sulfate, so write copper sulfate. Now quickly just remind yourself the reactivity series. Iron lies above copper. Yes, iron lies above copper. So iron will displace copper and it will form iron sulfate plus copper. And I have already told you this reaction. So this is your balanced chemical reaction. What will be the color change? So now remember, copper sulfate is blue solution. Copper is brown, but copper sulfate solution is blue. And this your iron sulfate solution is pale green, somewhat like gray. Remember this question. This question is also very important. As you can see, it has already been asked in various board exams earlier. Okay. Now, what next question? What observation is made when potassium iodide? Now, for that you must know the chemical formula thoroughly. Okay. So just write potassium iodide Ki, and it is added to lead nitrate. So it is PbNO3 twice. PbNO3 twice. Yeah. Now, this potassium is definitely more reactive than lead. Okay, it is the most reactive element. So it will replace lead and it will form potassium nitrate, and what else is there? Lead iodide, PbI2. Okay, so now both the compounds, the ions are exchanged, so it is your double decomposition reaction. Double decomposition, and basically this lead iodide is your precipitate. So this is your precipitation reaction. Precipitation reaction. And yellow precipitate of lead iodide is formed. We have already seen the example few slides before. Next question. You all know how to balance a chemical reaction, beta. Okay. A balanced chemical reaction is those reactions in which the total mass of reactants is always equal to the total mass of products, because it follows the law of conservation of mass. Okay, that's why we have to balance the chemical equations. So that is your first part. Okay, you can elaborate it. Okay, now coming to the second part, balancing chemical equations. Phosphorus burns in chlorine. Now phosphorus has multiple oxidation states. Okay, so P4, this is a polyatomic element. Okay, so P4 reacts with chlorine gas and it will form pentachloride. Pentachloride means Cl5, so it will be PCl5. Now balance it. Here there are 4 atoms, so if we put 4 here, now phosphorus is balanced. Now to balance the chlorine, 4 5s are 20, so put 10 here. So this is the balanced chemical reaction of first one. Yeah, yellow color. Yeah. Now the second one, barium chloride, BaCl2, sodium sulfate, Na2SO4. Now what it will form? It will form sodium chloride. So 2NaCl, I am writing the balance equation, and BaSO4. Now these are simple balance equations which has been asked. Okay. Yeah, that is a balance equation. That's correct. Now next question. Nitrogen gas reacts with hydrogen gas to form ammonia gas. So nitrogen gas N2, hydrogen gas H2, as most of the gases are present in the form of molecule. This is your reversible reaction and it will form ammonia gas, NH3. Now balance it. Since nitrogen has 2 atoms, so write 2 here. Now hydrogen becomes 6, so write 3 here. Now this is your balanced chemical reaction for the same question. Okay, is it clear? Now just solve these chemical reactions. Okay, and if you want to know the basics of these chemical reactions, there is a link in the description of this video where I have done the first part. In the first part, I have explained it in detail that how these chemical changes happen, how the chemical formulas are formed. Okay, regarding the valency, so you can go through it, then come back and solve these questions. Okay, it will be much easier for you. Okay, yes, 2NH3, 2 moles of ammonia gas. Next question, Some more chemical reactions to balance. Sodium hydroxide solution NaOH. It is treated with acetic acid. What is acetic acid? It is your ethanoic acid, CH3COOH. Now it forms sodium acetate. So sodium acetate, so what will it form? So this CH3COO is your negative ion, this H is your positive, here your Na is positive and OH is negative. If you remember this, then you can react H with OH, it forms water, and this Na reacts with this and it will form CH3COONA. And what it is? It is your sodium acetate, it is your salt. Sodium acetate. Okay, this is your double displacement reaction and it is already balanced, I think. Yeah, it is already balanced. But this is an important reaction. You must know how to do the double decomposition for such complex reactions. Okay, next. Next reaction, ethanol. Ethanol is your C2H5OH. Yeah, double displacement beta. C2H5OH. Now it is bound with ethanoic acid. Ethanoic is just we have seen in the previous reaction, CH3COOH. Okay, now if these will react, do you remember these reactions? This is a common reaction. You have learned it with the name of esterification. So ester is formed in this reaction. Ester is a sweet smelling compound that we use in making perfumes. Okay, so now in this reaction also, wherever there is H and OH, always water is formed. So first form water, then whatever remains, you can write it as it is. CH3COO, C2H5. So this is your ethyl, since 2 carbon are there, and acetate, since again 2 carbon are there. So it's ethyl acetate, your salt and water. Okay, is this reaction clear? I hope it's clear to all of you. Okay. Now next question, ethene. Ethene is a double bond, so it's C2H4. Now it is burned. Whenever it's burned in the presence of oxygen, reaction with oxygen to form carbon dioxide and water, and heat is released. Energy is released in the form of heat and light. Okay, so now see it, is it balanced? So carbon is 2 here, here it's 1, so put 2 here. Now carbon is balanced. Now hydrogen is 4, hydrogen is 2 here, so put 2 here. Hydrogen is also balanced. Now oxygen is 2, but here oxygen is 4 plus 2. So it's 6 oxygen atoms. So put 3 here. Now this is a balanced chemical reaction. But you can just, after this video, after the completion of this video will be there in the YouTube. You can just go through it, go through oxidation and reduction, and come with your doubts when we'll be doing our next class. Okay. Now this is your balanced reaction of ethene. Now some reducing agents, we have to find reducing agents. No, sir, I am just telling you the trick for identifying reducing agents. Just see the reaction that is going through oxidation. Okay, so now you have to find the oxidation reaction. Okay, and oxidation means addition of oxygen. So to find the reducing agent, just see where the oxygen is added. So here, as you can see, the nitrogen gains oxygen. So this is your oxidation. So this is your reducing agent, NH3. Now here, this F2 is addition of oxygen. So this is your reducing agent. Now in this reaction, this oxygen, carbon monoxide is converting into carbon dioxide. So the oxygen gain of oxygen. Okay. So now this is again your reducing agent, CO. Now here, hydrogen is gaining oxygen. So this is your reducing agent. So don't make it complex. For reducing agent, just see the addition of oxygen or the loss of hydrogen. For oxidizing agent, just see the addition of hydrogen or loss of oxygen. Now oxidizing agent, that means reduction. Reduction means loss of oxygen. So just see where the oxygen atoms are reducing. Okay, so if I can see here the oxygen atoms are reducing. So this is your oxidizing agent. Now here, as you can see, here the oxygen atoms are reducing in O2. So this is your oxidizing agent. Okay. Now here you can see this copper is losing oxygen. So this CuSO4 is your oxidizing agent. Now here this vanadium is losing oxygen. So your V2O5 is your oxidizing. You just have to write the compound. You don't have to discuss it on anymore. Okay, you can just save your time like that. Okay, now here you can see that H2 is reducing oxygen, so your H2 will be your oxidizing agent. Now here copper is reducing oxygen, so CuO will be your copper. CuO will be your oxidizing agent. Now next, a solution of potassium chloride, KCl, just write the compound. It is mixed with silver nitrate, AgNO3. This is a silver nitrate. Now what will be formed? Now as potassium is highly reactive, displaces silver, it forms potassium nitrate and silver chloride. And as we have seen, this silver chloride is white insoluble precipitate. So white insoluble precipitate. Okay, so this is the reaction. Okay, so which type of reaction is it? It is double decomposition, and in double decomposition also it is your precipitation. And what is forming? Silver chloride precipitate with white insoluble form. Okay, clear? Now next question. Now these questions are important. These are some reasoning questions. Okay, last few questions for you all. Okay, so now silver metal does not show any change. I am just quickly trying to tell you how to get these answers very quick. Okay, so silver metal does not show any change. So the shortcut of this is your reactivity series. You just have to remember the reactivity series. If you remember the reactivity series, I have already told you कि silver जो होता है वो सबसे कम reactive elements में से होता है. Okay, it is one of the least reactive elements. Okay, that's why it is not showing any change, because silver doesn't tend to react very easily. Okay, because of its reactivity. Second one, the temperature of reaction rises when aluminium is added. Now aluminium is a medium reactive element. Okay, now let me give you an example. If aluminium is added to any acid, for example hydrochloric acid, it will form aluminium chloride, AlCl3. You all must have seen this reaction. Okay, so it forms an acidic oxide, that is your AlCl3 acidic salt. Okay, so now balance it, and hydrogen gas is evolved. Now if hydrogen gas is evolved in the form of bubbles, if you keep a matchstick near it, okay, you'll see that the temperature is rising. What is it? What does it show? That it is an exothermic reaction. So if temperature is rising, it is showing like it is an exothermic reaction. Now you can balance this. You can put 3 here. You can put this balanced. Now for this you can put if I put 3 here, okay, and if I put 6 here and 2 here, now that is balanced. Okay, so now it is balanced. The third one, sodium metal reaction is highly explosive. Since sodium, potassium are those metals that are very reactive, that is posed at the top of the reactivity series, that's why they are very explosive metal reactions. Okay, now some gas bubbles are seen when lead is reacted with the acid. So for example, if I react lead with hydrochloric acid, now coming back to the reactivity series once again. So you have seen how many questions we have just solved only with the help of that reactivity series. So just after this class, just go through the reactivity series once. Most of the questions you will be able to solve. Okay, so now since lead comes above hydrogen in the reactivity series, so lead will readily react with hydrogen and it will displace hydrogen, it will form lead chloride, PbCl2, and hydrogen gas is evolved. And these evolution of hydrogen gas, you can see it in the form of gas bubbles. Okay, so you have to write the reaction also. Whenever there is a reasoning question like this, along with the theory part, you have to write the reaction also. Okay, so now balance it, put 2 here, now this is balanced. Okay, I hope these questions are clear. Okay, now, so our next class will be very soon. You will be intimated. For that you have to follow, okay, SISYA class, so that you can know about the intimation of the next class. Okay, it will be sooner and it will be of acid, bases and salts. Okay, till then go through these 2 videos of chemical reactions and equations, and if you are having any doubts, okay, you can ask me in that video also. Okay, now some few questions, last few questions, few MCQs. Okay, now any substance X. So we have to find X. Okay, and we have to write the chemical reaction also. Now it is of group 2. Now it is used in cement industry. Now there is only one element that is present in group 2 that is used in cement industry. That is your calcium. So from here you can easily identify that the element we are talking about is calcium. Okay, because it forms calcium oxide, CaO, that is a quicklime. It also forms calcium carbonate, that is a limestone. And it also forms calcium hydroxide, that is just slaked lime when dissolving in water. Okay, now this is present in bones. Now calcium is present in bones to increase its strength. Now on treatment with water. Okay, so calcium doesn't directly react with water because it is a medium reactive element. So calcium oxide reacts with water. So first you have to react that calcium with oxygen to form calcium oxide, that is the quicklime, balance it. Now this is balanced. Now this calcium oxide reacts with water to form calcium hydroxide that we are talking about. Okay, now balance this. This is 2, this is 2, and this is 2. Now this is also balanced. So these calcium hydroxide is just slaked lime. And it is a base since it contains OH. So it will turn red litmus blue. Understood? Next. Why do we store silver chloride in dark colored bottles? Okay, so silver chloride is AgCl. Okay, white insoluble precipitate. Okay, why we put it in dark colored bottles? So this is an example of photolytic reaction. So we have already understood that whenever the silver chloride comes in the presence of sunlight or any light, it decomposes to form silver metal and chlorine gas is evolved. Okay, so we store silver chloride in dark colored bottles to prevent its identity. Okay, to prevent its reduction into silver. Now, if a magnesium ribbon is burnt in oxygen, now you know the reaction, Mg plus O2 gives MgO, magnesium oxide will be formed. Okay, so this is a symbol reaction, you can balance it now, put 2 here, it is balanced. Now the twist is, if the burning is taken in presence of nitrogen, instead of oxygen, if I put nitrogen here, then what will be formed? Now that is an important reaction. Into it will be formed Mg2N3. Okay, so it will be your magnesium nitride. So this is something new which we haven't learned. So you must know this magnesium nitride that is formed. Okay, and if you will dissolve magnesium in water, so your X is magnesium. Okay, it is magnesium. Magnesium oxide, because we are asking here about compound, so it is magnesium oxide. Your Y is your magnesium nitride. Magnesium nitride. Okay, and if you dissolve magnesium oxide in water, it will form magnesium hydroxide. That is your milk of magnesia. Milk of magnesia. Okay, now you can balance it. So there is 2 oxygens. So if we put 2 here and 2 here and 2 here, is it balanced? Yes, it's balanced. Okay, so I hope it's clear. Next, zinc liberates hydrogen gas when react with dilute hydrochloric acid. We have just seen this example, Zn plus HCl. Now zinc is there in above to hydrogen in the reactivity series. So it will displace hydrogen and it will form zinc chloride and hydrogen gas will be evolved. Okay, hydrogen gas will be evolved. You can balance this. Put 2 and 2 here. Yeah, put 2 here, it is balanced. But when you react copper with HCl, with hydrochloric acid, copper lies below hydrogen. So since copper lies below hydrogen, now it can't displace hydrogen. So this reaction is not possible because of the reactivity series. Because of the reactivity of copper. Reactivity of copper is less than that of hydrogen. That's why it can't displace hydrogen from hydrochloric acid. Okay, I hope this is clear. Now, a silver article turns black when kept in open for few days. Okay, why? We have just discussed the same question in another form few slides before. Okay, because of the formation of silver chloride. Okay, if you put it out in open, okay, it turns black because of the tarnishing of silver. Now, why does it get tarnished? Now listen here quickly. Okay, now there are many oxides and sulfides of gases present in the atmosphere. Okay, so there is one gas that is present in the atmosphere, that is hydrogen sulfide. When you keep this silver article open for few days, it forms Ag2S, silver sulfide. Okay, it forms silver sulfide and hydrogen gas is evolved. Okay, you can balance it out. Okay, so silver sulfide. So to prevent the production of the silver sulfide and it goes black. Okay, now we say it as tarnishing of silver. So prevent this formation of your silver sulfide. Okay, now we can rub it with toothpaste again. Now toothpaste, if we rub it with toothpaste, it is a base. Okay, so it will again start shining. So it has turned acidic. Now we can rub it with the toothpaste. Now it will again be neutral and we can again get the shine of these silver particles. Okay, now these silver particles turn black. So this first part we have done. Now the black substance that is formed, that is just silver sulfide. Okay, and its chemical formula is Ag2S. Next. Okay, so that's all for today. Okay, now I hope that I have almost covered the whole chapter of chemical reactions and equations quite precisely. Okay, we have discussed so many MCQs, assertion reasons, PYQs also. I have tried to compile the last 10-year questions that has been coming from this chapter. Okay, and I have tried to tell you the way how to answer it within less time. Okay, so you can save your time also. Okay, now we are getting live daily with 10 different classes are going live for physics, chemistry, maths and biology. Okay, in our SISYA class. Okay, so kindly just download the SISYA class app. You can also download the SISYA class app to get more materials like this. Okay, and if you have liked this video, I hope you all have liked it. Okay, I have also tried to clear all your doubts. Okay, and we'll be having our live sessions on daily basis. Okay, daily at least one live session is going live. Okay, of different subjects. Okay, so kindly go through this video. Okay, and if you're liking it, just like, share and subscribe the channel also. Now the first part is there in the description. Okay, now go through it also, and if you are having any doubts, then please tune on. I'll be coming back within few days. Now I'll be coming back with acid, bases and salts. Okay, till then take care, study well, and all the best to all my dear class 10 students. Thank you.